All right, guys, welcome to Unit 6. Here we go. This is going to be Lesson 6-1. And the good news is a lot of this is a review from even 7th and 8th grade. So we're going to dive right in and talk about a ratio. A ratio is simply a comparison of two, and I'm going to say in parentheses, or more quantities. We can represent a ratio in three different ways. The most common way is as a fraction, A over B. You could also write A to B. And finally, we can do A with a colon B. Ratios can and should be simplified always. So I'm going to actually add on to that exclamation point. So as our first example, we see here a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. We have to write each ratio in simplest form. There's that kind of hint again for us. So trumpets to violins, I see we have 40 trumpets and we have 24 violins. Guys, when you go to write your ratio, we always want to do it in the order that it's telling me. So trumpets is going to be the numerator, violins is my denominator. I always choose to write my ratios as that fractional way, A over B. So from here, we just have to simplify everything. I believe that 8 could go into both, so we end up getting 5 over 3. We always want it to be the most simplified fraction. By the way, when we're saying simplest form, right, this also means no decimals. We want to leave this as a fraction, okay? Let's take a look at number 2. We're going to do flutes to clarinets. So I have 51 flutes and I have 39 clarinets. Both of these numbers are divisible by 3. So 51 divided by 3 gives me 17. 39 divided by 3 gives me 13. I can't go any lower than that. And it is okay if you notice on 1 and 2 how we have that improper fraction. I want you guys to take a moment and try 3 and 4, and I will pop back on so you can pause the video here and then jump back on to see if you got 3 and 4 correct. All right, let's take a look at number 3. We've got trombones to trumpets. So we have 16 trombones, and it says we have, where are my trumpets? 40 trumpets. So once again, I'm going to simplify. 8 goes into both of those. I get 2 over 5. That's my most simplified ratio. All right, number 4, we've got violins to total instruments. So I have 24 violins, but I have to figure out my total instruments. So I'm going to go up here and I'm going to add now, I've got the 40 trumpets plus the 39 clarinets, 24 violins, 51 flutes, and I'm also going to add 16. So when you add that up, my total is 170. So it's a little bit different. We had a little bit more work to do there. So I've got 24 over 170, and we can divide this one by 2. So I get 12 over 85. That's going to be the most simplified ratio. Okay. Now, in addition to regular ratios like this, where we're just comparing two things, we can take a look at an extended ratio. So an extended ratio is going to be a comparison of 3 or more. Quantities. Extended ratios are written as A to B to C. Now with an extended ratio, because there's 3, we are going to write it out in this format, right? Think about it. We would not say A over B over C. We couldn't write it as a fraction when you're dealing with an extended ratio. So we're going to use extended ratios to help us find some angle and side measures. So here's our geometry. It says the ratio of 2 complementary angles. So we have to dial back and remember that complementary angles are 2 angles that add up to 90 degrees. They're in the ratio of 3 to 7 we're going to find the measures of both angles. So guys, it's just as easy as this. You take that 3, attach an x to it. You take that 7, attach an x to it. Those are my 2 angles. They have to add up to be 90. That's how I'm creating this equation. From here, it should be smooth sailing for most of you. We're just solving our equation. I get x equals 9. I'm not done because this question wants me to find the measures of both angles. So now I plug that in. For 3x, it's going to be 3 times 9, or 27. That's going to be one of the angles. And then I'm going to find the angle measure for 7x, the other one. So 7 times 9, I get 63. If you notice, guys, these 2 angles, 27 plus 63, add up to be 90. All right, moving on, let's take a look at another one. Number 6, I'm actually gonna have you guys give that one a try. We'll come back to that in a minute because this one now is just supplementary. So you're gonna set that up in the very same manner that we did, except we're gonna know, hopefully, that supplementary is 180. Let's take a look at number 7, however, because that'll be a little bit different. So this one says the ratio of the measures of the angles in a triangle is 4 to 7 to 9. We have to find the measures of the angles. So class, we have to think about this. The angles in a triangle add up to be 180 degrees. So I'm going to make my equation 4x plus 7x plus 9x equals 180. We'll combine like terms, so 4 plus 7 plus 9, that's going to give me 20x equals 180. Divide both sides by 20, and we get x equals 9. Just like the last problem, we need to find the measures of the angles. So from here, we're going to have 4x, that'll be 4 times 9, or 36 degrees. I've got 7x, 7 times 9 is 63 degrees, and finally 9x. 9 times 9 gives me 81 degrees. These are the measures of my angles, 36, 63, and 81. I'd like you guys to take a moment and try 6 and 8, so just pause the video at this time. After you do it, hop back on so you can see if you got them right. All right, guys, welcome back. So hopefully you've had a chance to do 6 and 7. Just taking you through number 6 here. On this guy, we did the ratio of 2 supplementary angles is 4 to 1. So my equation, I chose to do 4x plus 1x equals 180. I solved that out, and I figured out that x was equal to 36. And from there, to find the angle measures, I plugged it back in. So my answers here were 144 degrees and 36 degrees. Moving on to number 8. This was very similar to number 7. It's the angles in a triangle. So my equation was 11x plus 2x plus 5x equals 180. Combine like terms, so I had 18x. I know that's a weird looking 8 there, so I'll fix that. This guy was 18x. I got x is 10, and then from there, I plugged it back in to the ratios, so I got 110 degrees, 20 degrees, and 50 degrees. So hopefully you guys got that too. You can check out the work and kind of see how I did it there. Again, pausing as needed to fill out your notes. All right, we've got a couple more that we're going to take a look at. On number 9, we've got the ratio of the measures of the sides of a triangle is 2 to 8 to 9. And this time, by the way, 2 changes. We're talking about the sides of the triangle, so we're not talking about the angle measures. And second thing is they're giving me the perimeter. So in this case, my equation is going to be 2x plus 8x plus 9x equals 76. If I add up all of the sides of the triangle, that's how I'm getting my perimeter. Again, we'll combine like terms, solve this out for x. So when I'm doing 76 divided by 19, I get x is 4. From there, to find my side lengths, I'm going to plug that back in. So I'm going to have 2 times 4, which is 8. 8 times 4, I've got 32, And finally, 9 times 4 is 36. These are going to be my side lengths, 8, 32, and 36. Okay, very similar, number 10. Your equation is going to be, well, these are my sides of the triangle, so we're going to add them up. 10x plus 15x plus 6x. It's telling me my perimeter is 217. So if I add up all my sides, it equals the perimeter. So we're going to first solve this out to find x. We combine our like terms, so I get 31x equals 217. Divide by 31, I get x is equal to 7. Now this question is slightly different because this one is only asking me to find the length of the shortest side. Guys, in this ratio 10 to 15 to 6, the shortest side is going to be the 6. So I'm only going to plug this back into 6x. So 6 times 7, 42, that's going to be the length of my shortest side. And I guess I should put 42 meters, a little m there to be proper with the unit, okay? All right, so review stuff there. We've seen ratios. Let's take a look at proportions. A proportion is going to be an equation that states two ratios are equal. A proportion is going to be written as A over B equals C over D. So you've got two ratios, they're equal to each other. We're in the world of equations. And to solve these proportions, we're going to use what's called the cross product property. I'm going to multiply my diagonals. So if I start with A and I multiply that diagonal, it's going to give me AD, or A times D, and I'm going to set that equal to my other diagonal. Oh, sorry, thought that was my highlighter. Here we go, take two, B to C. So A times D is going to equal B times C. And we'll take a look at that with some algebraic expressions and variables. So taking a look at number 11, class, when I go to do my cross product property, I always choose the diagonal with the variable first. So I'm going to multiply 2 times x to get 2x, and I'm going to set that equal to the product of the other diagonal. 4 times 7 is 28. Now we just solve. Divide by 2, I get x is 14. Okay. I'm going to show you number 13, so we'll just take a look down here. Again, I'm going to do the cross product property. I'm going to begin with the diagonal that has the variable. Now this is slightly different because in this diagonal, I have to do 19 times x minus 1. If you notice, I'm using parentheses, and that is mandatory. You have to multiply the 19 by everything over there. Let's take a look at my other diagonal. I'm going to do 6 times 13. I'm just going to write that in for right now because I don't have a calculator in my hand. Now we're going to solve this. So we're going to distribute our 19. 19 times x is 19x. 19 times 1 is 19. On the other side, I got my calculator. 6 times 13 is 78. And you know how to solve this from here. So I'm adding 19. We get 97, divide both sides by 19. Oh, goodness. Pushed it in the calculator wrong. Oh, gosh. 97 divided by 19. I'm getting a decimal, so I'm getting x is equal to 5.1. It goes on past that. It's like 5.105, but I'm just rounding it there. Okay. We'll continue taking a look at some of these odd ones. So moving to number 15, once again, class, I'm going to start with that diagonal that has my x in it. So I'm going to do 20 times 2x minus 9. Again, I'm using parentheses. Is going to equal my other diagonal, 10 times 9, or 90. We'll distribute 20 times 2x gives me 40x. 20 times negative 9 gives me negative 180. We'll add 180 to both sides. So I'm going to get 40x equals 270. Dividing by 40. And guys, we're going to get another decimal, and that is okay. So I get 6.75. Okay. Moving on to number 17, if you notice here, both of my diagonals are going to have variables in them. So it doesn't matter which one you start with. I'll just start here, 18 times x minus 20, parentheses are used again. My other diagonal, 3 times x minus 11. We'll distribute what we have, 18x minus 360, 18 times negative 20, got me that 360. Move into my other side, 3x minus 33. I'm gonna move my 3x, taking that baby to the mama. I'm gonna move stuff up here now. So I got 15x minus 360 equals negative 33. We'll add 360 to both sides, and I get 15x equals 327. And finally, when we divide by 15, I'm gonna get x equals 21.8. Lots of algebra today, but you guys are very good with that. Okay. Let's take a look at our last one. Our last one's going to be the biggest brain stretch that we have. So we have not seen this since probably algebra. Okay, I'm going to do the diagonal with the x, and it's actually 2 x's. So look what we have here, guys. We have to write this like x minus 1 in a set of parentheses times x plus 5 equals, we'll set that equal to my other diagonal. It's going to be 5 times 27. Now let's talk about how we're going to approach this left side of my equation. I'm multiplying 2 binomials together. Maybe you remember this from the good old days of algebra, but I'm going to use that FOIL method. So what I'm going to do is I'm going to multiply my first 2 terms. X times x gives me x squared. Next, we'll multiply our outer terms. X times 5 is 5x. Moving into the middle, negative 1 times x is negative 1x. And finally, we'll do the last 2. Negative 1 times 5 is negative 5. I'm going to go ahead and multiply 5 times 27. That gets me 135. Okay, right in the middle, 5x minus 1x is 4x. So I combine like terms right here. Okay, next, this is a lot of algebra review right here. I've got to get this guy in standard form, meaning I need to get it equal to 0. So I'm going to move that 135 over. Now I've got x squared plus 4x minus 140 equals 0. Okay, guys, now we begin to factor this. So to factor a trinomial, we're going to break it up into 2 binomials. Hopefully this is starting to come back. In my first spot here and here, I have to think about what times what multiplies to get me x squared. That's going to be an x. In my second spot, I call these guys my mystery numbers. They have to meet 2 requirements. They're going to need to multiply to be my last number over here. So multiply to be negative 140. And they're going to have to add up to be 4. So I have to start thinking about numbers that can multiply to be negative 140 and add up to be 4. So I might do, how about like 10 times 14? And maybe if I made that a negative 10, that could work. Negative 10 times 14 is negative 140. And if you add negative 10 plus 14, it's 4. So we have a negative 10, a positive 14. All right, final step, because this said to solve it, we have to do what's called the zero product property. So I'm going to split this down the middle, and I'm going to make two little mini equations. So I'm going to make it x minus 10 equals 0 and x plus 14 equals 0. So add 10, I get x equals 10. Subtract 14, x equals negative 14. Those are going to be my two solutions. And we always list our solutions least to greatest with these good old squiggly brackets. All right, guys, try the practice and we will see how it goes.